Could there be rogue planets floating in space between us and Alpha Centauri? Will the Chinese be beaming power from a space station to Earth? Will solar sails be used for propulsion in our lifetime? And in our free bonus question on Patreon, how Lagrange points work for different planets and moons. Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Visto Tutti, with rogue planets so plentiful, would there be some between Sol and Alpha Centauri? Could we detect them? We still don't know exactly how many rogue planets are out there. I mean, the estimates vary widely. At the low end, that there are about one rogue planet per star in the Milky Way. So there's 100 to 400 billion rogue planets in the Milky Way, which sounds like a lot, but that's how many stars there are. And there's probably 10 planets per star. But on the higher end, there could actually be dramatically more rogue planets than stars by many orders of magnitude. And so then that would mean that in fact the space between us and Alpha Centauri is heavily populated. Now finding them will be really difficult. So they're going to be cold. They're going to be just a little bit above the temperature of interstellar space. And the only way you can find them is with an infrared survey. And we've looked. The most powerful infrared telescopes that we have today probably wouldn't be able to detect a rogue planet coming within about 1,000 astronomical units of the sun. So we have to get very close for us to be able to observe it. But if it turns out that there are a lot of them out there, and it turns out this is something that's really important, then you can imagine people building more and more sensitive, larger surveys designed specifically to find rogue planets. But still, they're going to be really hard for us to find. The other way that you can find them is with occultations and gravitational lensing. So occultation, where something, an asteroid, a Kuiper Belt object, an Oort cloud object, passes in front of a star and causes that star to dim. And people have proposed that you build these giant surveys that are watching the brightness of all of the stars in the sky, looking for these just moments when an object passes in front of it. And if you have two surveys looking from two different places, then you have two angles, and then you will measure the occultation slightly differently from the two directions, and then that will tell you the size of the object as it passed in front of the star. One saw it dim the star for a second, one saw it dim the star for half a second, and then that tells you that a little bit about the object that passed in front. And so it could be, people have proposed that we could map out large chunks of the Kuiper Belt just by watching all of the stars in the sky for all of these occultations. And that could probably get us other objects as well, like Oort cloud objects, and maybe even rogue planet objects. But then the other way is you can use gravitational lensing, where you are waiting for some object to pass in front of a star, and then the gravity of this object will act like a natural lens. And so you could watch, again, all of the stars in the sky, and you're waiting for some of them to have this sort of distortion winking when something is passing in front, and that could tell us. And so, rogue planets have been discovered this way already. And so you can imagine a more comprehensive search where you're watching all the stars all the time, waiting for more of these gravitational lenses. So if it turns out there's a lot of rogue planets out there, it would be great to be able to chart them and find them. And then we could use those as stepping stones out to the greater cosmos. Looksy one, could you get rogue black holes that move around? If yes, what damage can they do to our solar system? I got some terrible news for you. All black holes are moving around. That all of the stars in the Milky Way are all moving in, they're moving around roughly the galactic disk as they go around. It takes about 225 million years for the stars to complete one orbit, but the stars are bobbing up and down in the disk of the galaxy. They're moving side to side. They are interacting gravitationally with each other in these three-body interactions. And so nothing remains. It's like this NASCAR track with cars going back and forth side to side. And so there are black holes that are moving in this collection of stars. And every now and then a black hole gets close to a star and causes a bad day. It can disrupt the planets in the system. It can even gobble up the star itself, but it happens very rarely. And so if a black hole came through the solar system, even if it wasn't very close to the solar system, it would cause mayhem. It would start to disturb the orbits of the planets. If it got close enough, it would start to really kick out planets from the solar system or crash them into the sun or consume them. So it would be a very bad day. But when we look at our solar system, it's been around for 4.6 billion years, and we don't see any obvious signs that a black hole came through here in that entire period of time. And so we can feel pretty confident that we won't see a black hole in our lifetime, in the life of the sun, because it's a very, very rare event. But it's not a non-zero event. Like right now, somewhere in the Milky Way, there is a black hole that is disrupting a planetary system right now. Or maybe it's happening multiple times. There are 100 million black holes in the Milky Way. And you don't even need a black hole. Like a neutron star would be a bad day. There are 1 billion neutron stars in the Milky Way. And you don't even need a neutron star. A white dwarf would probably be an unsettling companion to make its way into your solar system. And there are 10 billion white dwarfs in the Milky Way. So, you know, it's a dangerous place out there, but also it's really big, and these kinds of things happen very rarely. So don't worry about it. KoiJoiJoe is the Chinese proposal to make an in-space solar array that will wirelessly send energy back to Earth via microwaves real and realistic. So people have been trying to research the feasibility of space power for decades. You know, like I'm sure you could go back into the NASA archives and find proposals for space-based power back in the 60s, the 70s, I guess whenever solar panels were developed. And people have continuously tried to investigate whether or not it's feasible. And the answer is always that it's not feasible. And it's not that it's not possible. Like, could we launch a spacecraft into space? Yes. Could that spacecraft collect power from the sun with solar panels? Yes. You know, we've done this. Okay, great. Could you beam that power hundreds of kilometers to the surface of the planet with microwaves? Theoretically, yes. I mean, we have microwave transmission towers that are able to communicate. You're going to get a power loss. You know, exactly what that's going to be, you know, will have to be figured out. But right now, it's so expensive. Like, the one advantage that you get from sending your power harvesting satellite to space is that it can operate 24/7. Great. The downside is the entire ludicrous cost of sending a satellite into space. They cost hundreds of millions of dollars for just the launch in some cases. Not to mention the cost of the satellite itself. And it's going to have to be big because it's going to need solar panels to be able to collect this light. So, you know, there are plenty of people who have done very realistic calculations of what it's going to take. And it always just ends up being just build solar panels on the ground and a battery. And then that gets you what you need for a fraction of the price. That we're going to need to see spaceflight become several orders of magnitude cheaper before space-based power is going to work. Now, there are applications where space-based power makes sense, but it's not in like, let's provide baseload power down here on the surface of Earth. It's going to make sense where you've got places where it's really hard to send power, like the North Pole. Say you've got a research station in Antarctica and you want to be able to send them power. Maybe that makes sense. Or you're going to have a spacecraft in the permanently shadowed craters on the moon and you want to be able to send them power. Okay, use microwaves to send them power. But just for like sending power from space to Earth, every person who's ever tried to make this math work realizes that we are still multiple orders of magnitude away from this being a feasible business idea. And instead, they just go and they put up a solar panel and a battery. It's time for a shout out to our new patrons at the $5 level and above. Max Elazer, Greg Texiera, SD, Kent Linkletter, Stephen Thomas, Tyler Kosakowski, Macduff, Brady Cox, Schaff, and Wayne C. Join our community at patreon.com/universe today. KK14M, do we even know if beamed power will harm the atmosphere? Wouldn't it superheat it? So this is one of the concerns that we will have about beamed power from space, is that you are taking heat that would have gone past the Earth and you are redirecting it down onto the surface of the planet, and you're going to be heating up the planet. And it's going to be insignificant in the beginning and you can compensate for it. And, it's green energy. You're not pumping out greenhouse gases. But eventually, if we actually do that a lot, yes, we will be increasing the temperature on the planet and will eventually become unsustainable. There was a paper that came out about a year ago where people were doing the math for, even if we produce green energy, that we will eventually heat up the planet Earth just by the amount of energy that we are absorbing from space. And there was another paper that we reported on Universe Today last week about Dyson spheres, that if you surround the solar system in a Dyson sphere that is, say, about the orbit of Earth, like a little beyond the orbit of Earth. So Earth can be within the Dyson sphere and still be getting sunlight. And then you got this Dyson sphere, this oven around it, that you're going to be increasing temperature. And that even if it's around, like a little bigger than the orbit of Earth, you're going to increase temperature on the surface of the planet by like 100 Kelvin. Like, you'll wipe out all life on Earth. And that it's only when you get your Dyson sphere all the way out to about the orbit of Uranus will you only increase the temperature by about 1 Kelvin. So like, that's sustainable. But to build a Dyson sphere as big as the orbit of Uranus is ludicrous. And don't get me started on what it would take to build a Dyson sphere at the orbit of Uranus. Somadove, Fraser, what are your thoughts on solar sails? Do you think we will have one sent to study Earth-like planets in our lifetime? I love solar sails. They're really cool because you can just use the power of sunlight, radiation pressure to be able to move. You don't need to carry your propellant on board. That we could put solar sails into orbit and they could move from planet to planet, moon to moon. They could do station keeping and not require any propellant. And I'm just like, there have been some solar sail missions that have been done. There's more in the works. People are trying to figure this out, but I don't understand why we're not seeing many solar sails flying all the time, that there aren't solar sails as emergency backup propulsion systems on every spacecraft. It seems like a total natural fit. And then the next thing, the thing you're talking about is laser sails, right? If we want to be able to go and send a spacecraft to another star system, that you can then fire a laser and accelerate your solar sail to relativistic velocities. Will that happen in our lifetime? No, I don't think so. No. Maybe not my lifetime. I'm 53. Will it happen in your lifetime? I don't know how old you are, but we're still a long way from making this technology work, that we have to scale up the lasers that can fire. We have to invent new kinds of materials that can handle the power of the laser. We've got to miniaturize our technology to be able to fit as a very small payload, and then also be able to last for decades, to be able to travel from star system to star system. So it could very well be that you will see that kind of technology working when you are as old as me. But maybe you will go to your grave and we still won't have been able to reach out to another star system. But that's okay. I mean, there are things that are happening that we get to be a part of that other past civilizations could only have dreamed to see. Abdul Samad Kholia. How can I work on interstellar travel? I recently graduated as a mechanical engineer. You were born too early to work on interstellar travel. The reality is that the kinds of energies involved, the kind of technology involved for us to be able to get from here to another star system in a human lifetime is still right at the very bleeding edge, over the horizon of the technologies that we can do. But that said, we exist in the long line of human history. And so the best time to get involved in this process is right away, right now. And so, if you've recently graduated as a mechanical engineer, that's fantastic. I don't know what your specialty is, but you probably want to try and get work with some kind of space agency. So whether you work with NASA or ESA or JAXA, there are a lot of good space agencies, even China, around the world that are working on a lot of the fundamental technologies, both the kinds of technologies that will make existing missions move within the solar system, but also the kinds of underlying technologies that may eventually carry us to the stars. But there aren't a lot of those kinds of technologies that are really viable, that we've got lots of ways that we can imagine moving within the solar system more quickly. You've got fusion drives, you've got electric propulsion, you've got electric sails, magnetic sails, plasma sails, there are rail guns and laser sails. And so there's like a whole bunch of ideas that will allow us to move around within the solar system. But to cross the gulf from star system to star system, there's really only a couple of options. One is using a laser sail, where you fire a really powerful laser at a solar sail and then you accelerate it to relativistic velocities. It's able to move without having to carry propellant on board. And then the other possibility is antimatter. That's really the only fuel that we know of that can be dense enough to be able to provide the kind of kick that a spacecraft is going to need to be able to move to another star system. And so there aren't a lot of people working on either of those things, but there aren't none. So on the laser sail side, you've got the Breakthrough Starshot Foundation, and they are investing tens of millions of dollars in various companies that are working on this kind of technology. And so there's a lot of smaller firms that are investigating all the different bits and pieces that will make up a laser sail. You've got the materials engineering for the sail, to be able to make more and more powerful lasers. You've got miniaturization of the various components that are going to go on the spacecraft. So there's a lot of this work, and not just necessarily just, you can't go and join a company or a space agency that's working on a laser sail. Like, nobody really is. But there's a lot of this underlying technology that's in development today that will then be played out in the next couple of decades. Now, we're probably not going to see attempts to go to other star systems soon, but we will probably see this underlying technology get used robustly here in the solar system. So you're going to see people going from, say, here to the Kuiper Belt, here to the Oort cloud, here to the solar gravitational lens. And a lot of that technology is going to be these laser sails. So I would research the tech stack of the kinds of technologies that are going to come together to make that kind of thing a reality. You're looking, like I said, in the material side, you're looking at the miniaturization side, you're looking at the laser side. There's a lot of underlying physics that needs to come together, and they're going to need people to play a part in that. And then the other side is the antimatter side, and that's a totally different beast, right? You've got to be able to generate and produce antimatter at scale. You've got to be able to store and contain it. You've got to be able to use it safely without blowing up your spaceship for long periods of time. And there's a lot of the underlying technology to maintain a spacecraft for long periods of time with maintenance and repair and things like that. So I would do research into the technology stack that you think is going to play into creating an interstellar mission. And then I would try to get involved, find out the people who are actually doing this work and get involved with them to be able to participate in that research. It's, and yet, if you fail to be working on an interstellar spacecraft, you will end up working in aerospace. You'll end up working on space exploration. You'll end up working on really interesting projects that will inspire you for the rest of your career. So I'm excited. I'm jealous that you are sort of at the very beginning stages of being a mechanical engineer with all of this exciting stuff that's happening. I wanted to be an engineer. I went to engineering originally, and I would have graduated from engineering 35 years ago, right? And began my career then. But, now there's a lot more exciting projects that are happening. And so I think this will go really well for you. So keep at it. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call this Q&A Plus. This week's bonus question is all about how Lagrange points work for different planets and moons. All right, those are all the questions that we had this week. Thank everyone who put your questions into the YouTube comments, as well as everybody who showed up for the live stream, the 2-hour show that we record once a week. Now, I'm going to have a notification for the next event. It's here on the channel. So if you want to be able to catch this live, definitely go and check that out and make sure you get notified for when it happens. Now, I want to talk about helping spread awareness of smaller YouTubers. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bear Lake Roofing, Brian Body, Caradwin, Chuck Hawkins, Commander Balak, Cy Nelson, David Gilton and David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, James Clark, Jeremy Madden, Jim Berg, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Modso, Paul Robach, Ren Kaidu, Robek, Sean Sargent, Stanislav Zorajev, Stephen Fowler-Munley, Thomas L. Skadron, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So a thing that I did a couple of months back, and I want to do this again, is I want to give shout outs to other YouTube creators that you think are up and coming and deserve more love. And specifically, I would love to show the people who have like 1,000 YouTube subscribers or less, people who are doing it right, and yet the YouTube algorithm has not found them yet. People are, they haven't built up this big following. And so I want you to take a second and either put the name of the YouTuber into the YouTube comments. Like, you can't put links. YouTube will slash those links. You could try, but otherwise just put the name of the YouTuber, of the channel, into the YouTube comments down below, and then I will grab a bunch of them and I will check them out and see if they meet my criteria. And if so, then I will try to give as much shout outs as I can to all of these YouTubers to try and drive more audience their way and encourage them to keep doing the right thing, which is to find and help spread and celebrate science here on YouTube. We've got lots of big channels that get a lot of audience, but there's a lot of people, that next generation, we want to try and encourage them. So so put that name into the YouTube comments. You can also send me an email. My email is listed here on the channel. Feel free to self-promote yourself if you want. That's totally fine as well, as long as you're you're focusing on science here on YouTube. All right, we'll see you next time.